Welcome back. This is our third class of factorization series, and along with factorization in today's class we will also solve problem sums on division using factorization method. So let's solve one by one. These are the 5 problem sums that we will be solving in today's class. In the first problem sum we have an algebraic expression and we have to factorize that. Now the rule of factorization in this type of quadratic algebraic expression is that we have to first see that what is the coefficient of this x. So here the coefficient of x is -1. Next we have to see that what is the multiplication result of the coefficient of x squared term and the constant coefficient. So here the coefficient of x square is -2 and the constant coefficient in this quadratic expression is 6. So 6 multiplied by -2 is -12. Now we have to express this -x as an addition of two such terms where the multiplication of the coefficients of those two terms is equal to -12. Like here, -12 can be expressed as -12 multiplied by 1. -12 can also be expressed as +12 multiplied by -1. -12 can also be expressed as 6 multiplied by -2. Another possible combination is -6 multiplied by 2. Then another combination is 4 multiplied by -3. And then another combination is -4 multiplied by +3. Now among these 6 combinations, if we take this and if we express as -4x plus 3x, then -4x plus 3x will be -x. So this -x, here we have -x, and also the coefficient of x is -4 and the coefficient of this x is 3. So if we multiply their respective coefficients, then it gives us -12, which is equal to the result of multiplication of the constant coefficient and also the coefficient of x squared term. So this algebraic expression will be written as 6 in place of -x we will write -4x plus 3x. -4x plus 3x is -x, and -x then multiplied by +1 is again -x only, and we have this square term -2x square. Now if we remove this bracket, then it will be 6 minus 4x then plus 3x and then minus 2x square. Now further if we proceed, then from these two terms also we can take highest factor as common. So here 6 means 2 multiplied by 3 and -4x means -2 multiplied by 2x. So 2 is the common factor here. So if we take that factor as common, then within bracket we can write 3 minus 2x, and from here also x is the common factor or highest common factor between these two factors. So if we take x as our common factor, then what we can write inside the bracket is 3 then minus 2x. So here what we can see is 3 minus 2x is the common factor or common binomial. So here 3 minus 2x will be one of the factors of that algebraic expression, and the other factor will be 2 plus x. So this is the factorized form of this algebraic expression. Next we will factorize this quadratic expression. Now this is same as the format wise, this is same as the previous one, and here the rules that we will be applying, that will be again same as before. So here the constant the coefficient of m square is 3 and the constant coefficient is 36. So it will be how much? It will be 108. Now the coefficient of m is 24. So we have to express this 24m as a addition of two such terms where the multiplication of the coefficients of those two terms will be equal to 108. Now the possible combination that we can represent the 108, this value, as a multiplication of two other terms is here 54 multiplied by 2, that is 108. Now again 108 can be written as 2 multiplied by 54, but that is same only, so we don't need to write this one. And now 108 can be written as 3 multiplied by 36 or 36 multiplied by 3. Again 108 can be expressed as 12 multiplied by 9 or 9 multiplied by 12. Again 108 can be expressed as 27 multiplied by 4 or 4 multiplied by 27. Then 108 also can be expressed as 18 multiplied by 6 or 6 multiplied by 18. Now among these 5 combinations, if we consider this combination, then here we can express this algebraic expression like this: 3m square. Now 24m can be expressed as 18m plus 6m. So 18m plus 6m, if we add, then that gives us 24m, and when 18 and 6, these two values we multiply, then that gives us 108, which is equal to this value, which one we obtained by multiplying the coefficient of m square and the constant coefficient. So 24 can be expressed as addition of these two terms. Now we have the constant term 36. So if we now remove the bracket, so it will be 3m square, then 18m, then we have 6m plus 36. Now between these two terms, the first two terms, the highest common factor, as we can see, is here 18 can be expressed as 3 multiplied by 6. So 3 is common factor. Again between these two terms, m is also a common factor. So 3m, if we take this as our common factor, then as a binomial we can write here m, and then here we will have 6. So 3m multiplied by m, 3m square, and 3m multiplied by 6, 18m. Now between these two terms, what we can see is 6 is the highest common factor. So if we take that, then as a binomial we will have m plus 6. So what we can see here is m plus 6 is the common factor, or one of the factors of this algebraic expression. So we can write this way: m plus 6, and the other factor that we will have here is 3m plus 6. Now what we can see here is that between 3m and 6 there is again a common factor, which is 3. So that again can be taken as common. So 3, and then if we take 3 common from this factor, it will be m plus 2, and here the other factor is m plus 6. Now in the beginning the expression was 3m plus 24m plus 36. So here if we analyze the coefficients of these three terms, we can find here that 3 is the common factor. So if we take 3 as the common factor, then what remains as the algebraic expression within the bracket is m square, then 3 8s are 24, so 8m, and then 12. So initially we can take our highest common factor between those terms in the algebraic expression, and the remaining expression that we have, then on that we can apply the factorization methods. So that way it will be easier to factorize this algebraic expression compared to this algebraic expression. So either way we can factorize, but finally we will be getting the same result only. The next problem is about division, where we have to divide this algebraic expression by this algebraic expression. So this is our dividend, this is our divisor. Here we will not apply long division method, rather here we will be applying the factorization method. First we will factorize the dividend, and we will see that after factorization, one of the factors, mostly it will be equal to the divisor. So first let's factorize the dividend. So here the expression is algebraic expression acx square, then bc plus ad multiplied by x, and then bd. Now if we remove the bracket, so it will be ACX square, then it will be BCX, and then ADX plus BD. Now between the first two terms, what we can see is X is common, then C is also common, so that is the highest common factor. So if we take that term or that factor as common, then what remains inside the bracket is A and here X. So Cx and Ax, if we multiply, we get SCX square. And from the second term, what remains is B. Now between these two terms, what we can see is highest common factor is D. So D, and then within bracket it will be again Ax plus B. So what we can see is here Ax plus B is again the common factor between these two terms, and so we can take that as common. If we do that, then the other factor after factorization will be Cx plus D. Now what is our divisor? Here it is Ax plus B. So when we will divide this dividend, that means we are dividing Ax plus B and Cx plus D, right? Because this is the factorized form of this algebraic expression. So this dividend, when we will divide by this divisor Ax plus B, as in the numerator and denominator we have this common factor, so they will cancel each other, and what remains as quotient of this division is Cx plus D. So this will be our result of division. So this is the way how we divide using the factorization method. Now the next problem sum is also about division using factorization method. So let's factorize the dividend. So again we can see here this is a quadratic algebraic expression. So again we will follow the rule that we have seen for the first and second problems. So here when the coefficient of x square, which is 1 by 4, will be multiplied by constant coefficient which is minus 12, then the result of multiplication will be minus 3. So this term minus half, this will be expressed as a summation of two other terms such a way that the summation of their coefficients will be minus half and multiplication of their coefficients will be minus 3. 1 by 4 x square, then this minus half can be represented as 3 by 2 and then minus 2 and then x and then minus 12. So 3 by 2 and minus 2, if we simplify this, then it will be 3 then minus 4, right? So it will be minus half, and when 3 by 2 and minus 2, these two values will be multiplied, it will be what? It will be minus 3, and that is equal to this value. So we can easily write, or we can easily represent as the summation of these two values. Now if we simplify further, it will be 1 by 4 x square, then from here it will be 3 by 2 x, then from here it will be minus 2x, then here it will be minus 12. Now between these two terms, what is the highest common factor? Here x is one common factor and also half is another common factor, so x by 2. And if we take that value common, that factor common, then what remains from the first factor is x and then another 2, x by 2. So x by 2 and x by 2, it will be x square by 4. And from the second term it will be only 3. So x by 2 multiplied by 3, it will be 3 by 2 x. Between these two terms, what is common is the common value is minus 2. So if we take that as common factor, then here inside the bracket it will be x, so minus 2x, and here it will have plus, and here we will have 6. Now what we can notice here that in the first term we have this factor x by 2 plus 3, but in the second term we have x plus 6, but these two factors are not same yet, but we can make them same. How? Now if we rewrite this x by 2 and then x by 2 plus 3, now inside this bracket in this factor we have x and we want x by 2. So from x, how we can obtain x by 2? Let's write x by 2 first here, and if we multiply this x and minus 2, the result is minus 2x. Now we have to multiply x by 2 by such a term so that the result of multiplication will be again minus 2x. So what will be here the term? It will be minus 4. So minus 4, when it will be multiplied by x by 2, again the result of multiplication will be minus 2x, which is same as this. And now if we take minus 4 common, and here the original term was minus 12, so what will remain inside this as the second term? It will be 3. So now these two factors are same. So we will take x by 2 plus 3 as one of the factors, and the other factor will be x by 2 minus 4. Now as we can see here, the divisor also x by 2 minus 4. So in place of this algebraic expression, if we write x by 2 plus 3 and then the other factor x by 2 minus 4, and if we divide by x by 2 minus 4, that divisor, then this and this, they are common in the numerator and denominator, they will cancel each other, and what will remain as quotient of this division is x by 2 plus 3. Now the next problem is also related to division by using factorization method. Here our dividend is a to the power 12, then we have a6 b6, then we have b to the power 12. Now we can simplify, we can divide, or we can factorize this dividend the way we have done for other problem sums, but here let's apply some other trick. Now what it is, we know this identity x square plus y square, and that is what? That is x plus y whole square minus 2xy, right? Now a to the power 12, if we rewrite this as square of a to the power 6, now b to the power 12 also can be written as square of b to the power 6, and then the second term that we had in the original expression, that was a to the power 6 multiplied by b to the power 6. Now this resembles this identity x square plus y square, where x is our a to the power 6 and y is our b to the power 6. So if we now write as a to the power 6 plus b to the power 6, means x plus y, then whole square, and then minus 2xy. So 2x is a to the power 6 and then y is b to the power 6, and now we have this term a to the power 6 b to the power 6. So if we simplify further, it will be a to the power 6 plus b to the power 6, then whole square, and from here we will have minus a to the power 6 b to the power 6. So what we can see here is this, we have one square term, so we will rewrite that, and then we have another term here where the power of both the variables a b is 6, and that can be further represented as a cube b cube and then whole square. So again this resembles what? This resembles this identity x square minus y square, and that is equal to, we know this, x plus y, x minus y. So this can be further written as a to the power 6 plus b to the power 6 and then plus a. This time this is our x and this is our y. So y is a cube plus b cube. So this is what we will write, and then we have a to the power 6 plus b to the power 6, then minus a cube b cube. And this is the factorized form of this algebraic expression, and this will be divided by this divisor, where we can see a to the power 6 plus b to the power 6 and then minus a cube b cube. That means we already have this factor in our dividend. So if we divide this factorized form of the algebraic expression by this factor, then the common factor will cancel each other, and the quotient value will be a to the power 6 plus b to the power 6 plus a cube b cube. So this is our quotient, or the result of division. So I hope you have clearly understood the logic, the explanation of these problem sums. With this, I end today's class. Stay safe and stay healthy. Thank you.